Example 4. Given the following function, f of x equals 2x plus 5 if x is less than negative 1, and x cubed if negative 1 is less than or equal to x is less than or equal to 1. Part A, find the domain of f. So we're given a piecewise defined function here with two distinct pieces. When x is less than negative 1, this graph looks like a 2x plus 5 graph, a line. When x is between negative 1 and 1, including those endpoints, it looks like a cubic function, the increasing snake shape. The x values are defined for each piece right here in the equation. So the domain of my left piece, so first let's label this as our left piece, its domain is x less than negative 1. So we know in interval notation that would be negative infinity to negative 1. Then the right piece is when negative 1 is less than or equal to x is less than or equal to 1. And I want to encourage you guys to read this instead of the way I just read it. Read it as x is between negative 1 and 1. So we have equal signs on those endpoints, so we know we want brackets. So bracket negative 1, comma 1, bracket. So this function f is these two pieces joined together. So the domain of f will be these two individual domains joined together. So the leftmost point would be negative infinity, goes all the way to negative 1, not including 1. Then it picks up in the right piece, including negative 1, and goes all the way to 1. So this graph is going to go from negative infinity to 1, and we put the bracket on there to include the 1. Part B, find the intercepts. So we know to find x-intercepts of a function, we want to substitute in a y value of 0. In a piecewise defined function, in this case specifically, we have two pieces. It's possible that each piece could intersect the x-axis. So we have to check each piece for their own separate x-intercepts. So I'll got my x-intercepts here. So first I'll look at my left piece, the y equals 2x plus 5. So I'll substitute a 0 in for my y, subtract the 5 from both sides, divide by 2 on both sides. So I would get an x-intercept of negative 5 halves. So if I graph the entire y equals 2x plus 5 line, it would intersect the x-axis at negative 5 halves. So what we have to check in piecewise defined functions is, does this x-intercept occur in this piece? Remember, we're only taking a piece of the 2x plus 5 line. So negative 5 halves, it is less than negative 1. It does fall in the domain of this piece. So then I know I do have an x-intercept at negative 5 halves, 0. If instead I got a positive 5 halves, for example, that would not fall within the domain of this piece, negative infinity to negative 1. So that would actually not be an x-intercept of this function. But because negative 5 halves does fall in within this region, we know this is an x-intercept of this piecewise defined function. Now let's check our right piece. So y equals x cubed. So I'll substitute in a 0 for y. Take the cube root of both sides. So I get 0 is equal to x. So now I want to check, so if I graphed an entire x cubed graph, it would cross the x-axis at 0, which we actually know that's one of our parent functions we should be familiar with. But we want to check, does 0 fall within the domain of this piece? Yes, it does. 0 is between negative 1 and 1. So then we know this piecewise defined function also has an intercept at 0, 0. Now we can already see, if it goes through an x value of 0 and a y value of 0, we can actually already see that the y-intercept is right here as well. But just to verify the algebra, when we look for a y-intercept, we know a function can only have one y-intercept. If it had more than one, it would fail the vertical line test. So what we do is we look in the two pieces, in this case, does x equal 0 in either of these two pieces? Well, it doesn't equal 0 here. This is when x is less than negative 1. X would equal 0 in this piece. So it means I would only have to substitute in an x value of 0 in the right piece. Again, we already know in this case because it happened to be 0, 0, but I do want to make sure we verify the algebra for other cases where it wouldn't be the origin. So when I would substitute in, I'd put the 0, 0 cubed in just that right piece, which would obviously give me a y value of 0, which we already verified right here. So we have two intercepts in this function, -5 halves 0 and 0, 0.